A fair coin, they kind of reverse the writing. They meant to say a fair coin is flipped 2 times. What's probability 2 heads, 2 tails, blah, 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 blah. Okay, so if you're going to flip a coin twice, I'm gonna write out the branching involved in flipping a coin twice. So when you flip a coin twice, what's going to happen? Well, first time you flip, you're going to get either a heads or a tail, right? And what's the chance you're going to get heads? I'm going to write the chance right on the branch. A half. What's the chance you're going to get tails? A half. Right? When you flip a coin, there's a half chance of head and a half chance of tail. And then you're going to flip it again. Second flip. The second flip is going to be heads or tails as well, isn't it? And again, it's a half chance of head and a half chance of tail, half chance of head, half chance of tail. So notice this is the second flip. And over here we have the first flip. First flip, second flip. And over here we have the results. And so what are the results? Well, the results, let me just write them out. It's head, tail, tail, head, tail. So the results, as you go, and remember in these trees, when we make these trees, we're always moving from left to right in the trees. So this is head, head. That's why the result is head, head. If we go the other way, we go head and then go down, tail. So that's why this result is head followed by tail, head, tail. Whereas down here is tail, head, tail, head. And this is tail, 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 tail. We all seeing that? So as you move from left to right through the tree, tail, tail, and tail, head, etc. Okay, now how do we? What's the probabilities? What you do is you multiply the probabilities as you move from left to right. So it's going to be 1/4. How do I get that? A half, head, and then head again, a half. Head, head, a half, a half. Are making sense? So just as you move from left to right. The other ones are also going to be a half times a half. A half times a half as you move from left to right through the table. Half times a half. Okay, so up here, what's the probability of 2 heads? Well, 2 heads is 1/4. So I'll write that down now for us. 1/4. What's probability of 2 tails? Well, 2 tails is also 1/4. What's the probability of first a head, then a tail? Well, that's right here, isn't it? First a head, then a tail, 1/4. These are all coming out of 4. Next one, first a tail, then a head. Right here. First a tail, then a head, 1/4. And last, 1 head, 1 tail, any order. Now any order, that's going to be both of these, isn't it? 1 head, 1 tail, any order is going to be 1/4 plus 1/4, which is 2/4. Now you don't even have to reduce fraction. I mean, you could, if you want to, you could reduce it. It's a half, or you could type in the decimal 0.5. It doesn't matter. So that makes sense on that last one. That last one was a little more tricky. They asked 1 head, 1 tail, any order. So any order, I would count head, tail, or tail, head. That's 1 head and 1 tail, any order. That's a 1/4 and a 1/4. That's 2/4. So you add those up. When you have more than one option, you add up the probabilities. How did I get the probabilities? I multiplied across the tree, right? It's always as you move from left to right. So head, 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 head. A half times a half, a fourth, etc. So left to right, and then if you have two possibilities, like head, tail, or tail, head, you add them up. So there we go.